All right, we'll get started. Hope all of you had a great conference. I know we are headed towards the end, but the most exciting 20 minutes are here. We have talked a lot about open networking, SONiC in this forum. And open networking or disaggregation started with the hyperscalers, and it has now proliferated to tier 2 clouds, to service providers, and enterprise data centers. You actually just heard AT&T talk about it. Thank you, Lemire. We had Deutsche Telekom yesterday who talked about their deployment. In other forums, there are customers like LAN and Technicum VM and EPFL have come and talked about their deployment. So it is all becoming very real. A lot of these customers, after deploying this, are now coming to us and saying, hey, this disruption that now is proliferating in the data center can be extended to the campus or to the edge. And this is something that we are about to unveil, about to talk about, an end-to-end architecture for the LAN, for the campus that we're going to talk about today. My name is Hasan Siraj. I lead product management for our software and emerging silicon portfolio over in Broadcom. I'm joined here by Taras from PLVision, who's also representing Shasta Networks. So how did we get here? Shasta is a network as a service company, right? A lot of the founders there are from Ruckus Wireless. Most of you may know this company from their heritage in wireless networking. They've been working very closely on the TIP forum, on the Telecom Infrastructure Project Forum on Open Wi-Fi, right? Working with white box access points, open source network operating system, and cloud SDK, which is basically enabling cloud management for a Wi-Fi deployment. And as we see it, like wireless and LAN switching are like they fit hand in glove. I personally think that LAN switching's main role moving forward is building the best wired network for wireless. And this is why it made sense to extend this open Wi-Fi initiative to open LAN, which is also now becoming a TIP project and is under this umbrella. As far as Broadcom is concerned, most of you know us from providing silicon to all the large hyperscalers, large OEMs, but we also have an extensive portfolio of enterprise or campus or edge silicon as well. We are one of the largest contributors, as just Kamran talked about, to the SONiC and SAI projects. We've already made a lot of contributions on the edge side, so it made sense for this collaboration. And SONiC as an operating system, like we have talked about, it is now starting to gain a lot of traction on the data center. It made sense to extend it to the edge. Now there is work that needs to happen to extend it to the edge. It has to be put on a diet, to be put on lower-end platforms, and that's a lot of the work that has happened already and will continue to happen. Now, what are some of the goals, right? The first thing is there is a very extensive portfolio for data center switching that comes through the ODMs that are here and displaying a lot of this stuff in the booths. We want to make sure that portfolio is available for the edge and for the enterprise as well. We also want to make sure the lineup for the edge that's there right now is very focused on 48 port and higher end portfolio, right? You'll see 1 gig switches, you'll see multi-gig switches. But we want to extend this down to even 24, 16, and 8-port compact switches to cover all sorts of deployments. We have a chip called Trident 3X3 for the edge. We also have now boxes coming out on Trident 3X2. One other effort that we are doing is these X3 and XT switches, they actually have built-in ARM processors, and we are also going to be enabling SAI for ARM, so that instead of having a separate CPU, an x86 CPU, you can do all of this on the chip itself, essentially bringing down the cost of the solution because this is a cost-sensitive market. And of course, as we look at Wi-Fi 6 and 7, we want to make sure that this portfolio supports everything from PoE, PoE Plus to PoE Plus Plus up to 90 watts of power. You heard about the Unified Management Framework. It's a key work that we have done, and that gets leveraged here as well. There is a GNMI interface, a modern interface that is getting leveraged in this deployment. Of course, we will make sure that the right feature set, we are not about just shoving a lot of features in here, but the right features that are required for this deployment show up. And there is a complete validated and hardened system that can be available to the end customers. Taras will show you how ZTP works over here. And of course, key to this is the cloud management. So what we are really talking about is a complete solution. You have Wi-Fi access points, you have white boxes, you have got an open source operating system, and you have cloud management, which is also built on open APIs that will be available. So the goal over here is to at least show you the architecture, and then we want to show you a demo, because this is becoming real. Yeah. Thanks, Dev.
Thanks, Hasan. So, tech stack, how it is done. So the main core of this happening is the Sonic running on the platform. And why we are so confident about this, because this is Sonic from Broadcom, it does work, thanks to that. And the GNMI interface, the management framework that's introduced by Broadcom is also the key part of this. So on top of this GNMI interface, there is a new so-called uCentral client container. Okay, this one here. Yeah, so on top of this GNMI interfaces, that is the part of the management. Is the part of the management framework in Sonic. There is a uCentral client. uCentral is the cloud management protocol, which is now heavily used for the open Wi-Fi. It's proven it works. And what we are putting it on top of the Sonic and enabling this uCentral client to configure and to work and basically do the whole lifecycle management of the Sonic through this GNMI interfaces. And basically what's happening here is we have the box which runs uCentral client, which runs on top of the Sonic. What's interesting part here, as you can see, there is a PKE cert. This is the most, I believe, important part of this overall solution. This is the global-wide zero-touch provisioning. What does it mean? Each and every box that's certified for this tip has the issued certificate for this specific box. When system starts, it searches for the internet. Where internet is found, basically it connects to the global redirector and finds out to where I should connect, to which cloud I should connect. And then there are a list of clouds it's supported. It connects to it and grabs all configuration from it. Wherever you want to hard reset the system and move to another cloud, just hard reset it, and still it will be connected to the cloud whatsoever. So with this, the global ZTP, it allows you to control the box without even going inside the box. We know that Sonic, the previous talk they said there is no Sonic experience. This is the way how we are trying to resolve this issue. You're saying you don't need Sonic experience here. Sonic is the trusted platform. It's the proven platform to work. Let's allow cloud to manage it. So getting back to the certificate, as I said, when it starts, it's go to the DigiCert tip server, asks about where it should connect, gets authenticated, then connects to the cloud, provides a certificate which is used for building the secure channel and basically validating that this box is known and assigned to this client, and then starts to getting the configuration from the cloud. As of now, we are focusing on the layer 2 features, like the first step, which is done, and I will show in a demo a bit about them. And the next phases will be like the layer 3 fabric features. We will grow on and on and on to allow the network as the service for the enterprise without basically the hassles to know what network they are running to. How we are doing that? Okay. So, as we said, as the main integration point for this uCentral client is the GNMI interface from the Sonic. On top of it, we have the platform abstraction that basically abstracts the configuration from the full full snapshot of the config requested for the cloud and translate it to the transactions that requires by GNMI, GNOI. Additionally, via the GNOI, we do provide support for the operations, like system upgrade, like RTTY, save restore config. This is also part of this uCentral client. And we are subscribing to the events from the Sonic, like alarms, like changing of the port statistics, changing of the link status if we need so, and reports back to the client. And basically, as I said, we are not reinventing the wheel here. So all this works currently for the access points on the Wi-Fi with uCentral client running on them. And what we are doing, we are basically moving the same technology with a bit extending it to the switch use case, because we do believe that the Wi-Fi is great, but if we have bigger network, one access point is not enough for you, and you want to have the switch behind, and you want to control it as well. So you can build the fabric, you can build the faster migration, so you need to be on a switch as well. And okay, now this one doesn't want, it's a demo time. So for the demo, I will show you a simple video. I don't know if it will be seen or not. Okay, it's not shown. And no audio, nice. 1 second. Sorry for that. Okay. So basically here, we will talk about how to set up a remote branch intake in 10 minutes. Configure your branch, talk with your ODM to drop ship your white boxes, connect to the firewall, and grab some coffee. This is how it looks like when you are actually doing this with the software. You are logging into the software, you are adding a new venue. I speed it up a bit so we will not take too much time. Adding new office, setting the location for it. Then you go to that office, and here it's an interesting point. You can add manually your switches when you have them already, but if you order them to the drop ship from the ODM, shouldn't be doing that. This part, it will be done automatically for you. They will be assigned for this. So here, the switch is added because it was already on my location. Sorry, the ODM didn't want to send me the new one, so I had to add them manually here. Basically, I am adding these switches here. I'm assigning them to the venue. They are being recognized by the controller. Once they will connect to them, or if they are already connected, the proper status will be grabbed through the open source Tips Cloud SDK. And I'm adding the access points here. The first one, and there will be the second one. And what will happen next once this infrastructure is added either manually but automatically? We encourage to use automatic because it's much more easier for you. You don't need to know about what MAC addresses, etc. It's still visible on the hardware, but it's much more easier for you if you just use the automatic added. Then you are creating the network. Within the interface, you are defining, I want this Wi-Fi. There are some Wi-Fi's defined here. I want to create a new one. In our case, there is a QA team that will test of this whole solution, so I will create the Wi-Fi network for them. And I'm saying that this network will be password protected. And I'm setting the password here. And then I'm saying just that network is basically set already on the controller. And what I'm doing next is I need this network to be assigned. I'm assigning this network to the venue. What it means that the controller logic, the cloud logic, will understand, okay, this network has to be assigned to that devices running through the network. So as you can see, I didn't do any VLANs, I didn't do any routing. This all is encapsulated. It's simplified. You are talking about concept. There is still a way to do it. If you go deep inside, you can still do it manually. But the idea is to do it like in an encapsulated network. And this is what's happened on the remote location. You are taking the switch, taking the access points, plugging in, take the internet cable, connect to it, take the access point, connect to the switch, take the second one, connect the second one as well. As you can see, there are no power because it's PoE enabled. Then what you should do, it's basically you need to grab a chair. It's important step of it. Take some coffee or tea based on your preference. Drink it, and start to think how you can make this better. Understand it's already perfect. Take some more coffee, and your network is done. Questions? Yes. Yes, 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 yes. And sorry, I missed this one. Yeah, so basically, what about high availability? It's an interesting point. The upgrades are done in the background for you. As the part of the cloud, it scheduled the upgrades which being pushed to your equipment. You can snooze it, you can basically delay them, but eventually you will be pushed to accept the upgrade. And this is the important point because this allows you not to stuck with a fragmentation of the versions. So your infrastructure is always on the latest and greatest version, which includes all fixes, all the functionality that you need to spread through your network. Definitely, how you apply your updates, different story. There is a special procedure. You can have the smaller like test area, then you will absorb it through the wider area. But the whole idea is the updates are hidden for you. You don't care about them. They will be done for you by the cloud as well. And please contribute to the enterprise, Sonic Enterprise and SAI features. Connect to the TIP Open Wireless Converged Wireless workgroup. It will be renamed anytime soon to the Open LAN switching. It's already happening within the TIP. And check about the OLS and Open Wi-Fi and Cloud SDK on the respective sites. Now I'm ready for questions here. Yes.
Is that orchestration going to be oriented to the OLS?
So the orchestration part, the Cloud SDK, the client itself, the protocol is open source as the part of TIP. So what's kept proprietary is the business logic on top. So you have, within your open source TIP infrastructure, you have the standardized Cloud SDK, and you can build your logic. If you want to have like simple tables, you fill in, this is your logic, you can do it. If you want to have the sophisticated one, you can build it on top. But the whole infra, the ZTP is there, the client will be there, the Cloud SDK is already there, so infra is already open source as the part of the TIP.
But all the, the day zero and that, this is, everybody will have to do their own.
You mean by day zero, by...
Like planning the network like we did.
yes, yeah.
Everybody has to bring it.
Yeah, you can do it as the part of your cloud business business value. For example, you can say, I will do it automatically for you, but as the part of the TIP open source, you have the channel and protocol how to communicate with remote locations and how to do the ZTP for them, how to deploy them in the automatic manner, how to upgrade them in automatic manner. But how you do the logic inside, it's based on the business logic of your cloud. It's a great question. So we've been working closely with this on Broadcom, and thanks for them. So we have the possibility to do the full upgrade quite easily, but we do understand that the full upgrade can be disruptive, and we are now working quite intensively to have this client upgrade only to allow ISSU for this part, because the Broadcom Sonic is stable enough. It's stable enough that it shouldn't do the interruption, and I believe maybe at some point we will do the support for ISSU from the Sonic perspective as well.
Yeah, the capability, right, that is well known, that is used all the hyperscalers called warm boot, right? That's a functionality that we can support, and that's certainly something that we're looking at. That was the full upgrade.
Yeah.
So that's, we want to make sure that it can work in this lower memory footprint as well, but that's certainly something at some point of time we will deliver. It is running right now. So I think Sonic is actually deployed, right? We had one of the customers in October, Technicum VM, who talked about their deployment. So it is running on what we call a Trident 3 X3 portfolio. There is an X2 chip, which is also out. There are a lot of data center management platforms based on X2, and I think that's why I want the hardware ecosystem to expand, right? A lot of the white box vendors are coming out with PoE boxes based on X2. So over the next year, I think I'm also hoping that we will also be able to run this without the x86 processor, right? On these chips itself, with the SI work that we are doing. But yeah, absolutely. Right now, it is running on X3 today, and it's deployed in production.
Yeah.
So, and I know, maybe I can go back to this if you're still interested. So the current, it's Edge Core ESP22, which is Trident X3 platform. It's up and running. The video I was showing there, it's the actual one. It runs actual Sonic. It runs actual client. It connects to the ZTP. It gets the configuration down, and Wi-Fi basically can connect to it.
How do you manage the volume of certificates? And the second question is like, how do you secure the certificates in the box?
Okay, this is quite interesting one. So the certificates, I believe, they fixed this one here. So the certificates are being pre-programmed by the ODMs. So there are a tips queue, and the tips queue has its own certificate burned to the flash on the special partition by the ODM, and then uCentral just logs in. And keep in mind the ideal world that it should not be any human interaction to the box once this system is completely closed. So by securing, as of now, they're just laying on the flash, but this is something that we will definitely take a look what can be done. And about updating, there is a special procedure on the open Wi-Fi. It's so-called Maverick. You can, when something went wrong, you cannot connect to the controller. So you want to fix it. The special Wi-Fi is being connected. You can connect to it, open the web page, and log into the device and upload the certificate via the web UI if you want so. Like a recovery option. But the protocol has the possibility to upgrade it.
And export the keys?
No. I mean, the key, you asked about certificates, not the keys. Yeah, but yeah, it's always the bundle. No. I mean, I do understand what you're saying, how to prevent that someone will pretend that they are there. The certificate is tied to the box. The certificate has mark of the box within its common name. And this is how it's being recognized by the controller. Okay, I know that box assigned to that specific, that specific client or venue. Then, if no more questions, thank you.